Welcome to The Explainer. Today we're diving into something that every Go developer working with the cloud absolutely needs to understand: how Kubernetes manages configuration and state. Getting this right is honestly the difference between an app that just runs and one that's truly scalable and robust.
So let's start with a basic question. How in the world does a cluster, which could be hundreds of different machines, coordinate to act like one single giant computer? How does it know what to do? It's not magic, I promise. The answer lies in having one and only one source of truth.
So here's the game plan for today. We're going to start with the brain of the operation, a thing called etcd. Then we'll talk about the basic building blocks, objects, and pods. From there, we'll get super practical for you Go developers and look at managing app settings with ConfigMaps and Secrets. And finally, we'll put those two head to head. Let's get into it. Okay, first stop, the absolute core of any Kubernetes cluster. This is the central nervous system, the source of all truth, a component called etcd. So what is etcd? Well, at its heart, it's a simple key value store. Think of it like a specialized database. And its one job is to store everything Kubernetes knows or wants. The desired state of your entire cluster. Every application, every setting, every network rule, it all lives right here in etcd. And what makes ETCs so perfect for this job are these features right here. Because it's distributed, there's no single point of failure. It uses a consensus algorithm called Raft, which is just a fancy way of saying all the nodes vote to agree on what's true, so the data is always consistent. But maybe the coolest part is the watch functionality. This lets other parts of Kubernetes get instant notifications whenever something changes, which is really the secret sauce behind all of Kubernetes' self-healing automation. Now, this is the key takeaway for any senior engineer or anyone on an ops team. Let me be blunt. The health of etcd is the health of your cluster. If etcd goes down, your cluster is effectively brain dead. Yeah, your running apps might limp along for a bit, but you can't deploy anything new, you can't make any changes, you can't scale, nothing. It is that critical. Okay, so we know where the state is stored, but what does that state actually look like? To get that, we need to learn the basic vocabulary of Kubernetes, and that starts with its objects. Think of Kubernetes objects like this. They are your record of intent. You don't tell Kubernetes how to do things step by step. Instead, you just declare the state you want. You write a file that says, "Hey Kubernetes, I want 3 copies of my Go web server running." And Kubernetes takes that declaration and works nonstop to make it a reality. And every single one of these objects you define, usually in a YAML file, follows this same predictable structure. You've got API version and kind to tell Kubernetes what kind of thing you're defining. You have metadata to give it a name and some labels, and then you have the most important part, the spec. That's where you describe your desired state, your intent. And that brings us to the most fundamental building block of all, the pod. As a Go developer, you think in terms of containers. You package your app in a container. But, and this is key, Kubernetes doesn't run containers directly. It wraps them inside a pod. The analogy here is perfect. If your container is a musician, the pod is their own private soundproof practice room. It gives them the network, the storage, and the isolation they need to perform. All right, listen up, because this is one of those concepts that you absolutely have to internalize. Pods are mortal. They are ephemeral. They can and will be destroyed and recreated all the time. This means you can never, and I mean never, rely on a pod's IP address. It's not permanent. That's why we need other objects, like services, to provide a stable entry point to our applications. So let's see that structure in a real-world example. Here's a super simple pod definition. You can see the 4 parts clearly. API version, v1, kind, pod. In the metadata, we give it a simple name, and then in the spec, we declare our intent. We want a list of containers, in this case, just one. We give that container a name and tell Kubernetes which image to pull. That's it. We've told Kubernetes what we want, and now it will go and make it so.
Okay, our pod is running our container. Great. But what about configuration? You know, database connection strings, feature flags, API endpoints. You should never, ever bake these into your container image. So how do we get that information to our application at runtime?
For all your non-sensitive data, the answer is a config map. It's exactly what it sounds like, a map of configuration data stored as key value pairs right inside Kubernetes. This is a game changer because it lets you use the exact same container image in development, staging, and production, and just point it to a different config map in each environment. And using one is really straightforward. In your pod definition, inside the container spec, you can add this and from section. You're basically telling Kubernetes, hey, I want you to populate environment variables from this source. Then you just point it to your config map by name. Kubernetes then takes every key value pair from that config map and makes it an environment variable inside your container. Now, in your Go code, you can just read it like you always have, os.getEnviron of your config key. It's clean and totally decoupled.
Config maps are perfect for regular settings, but what about the stuff you really need to protect? I'm talking about database passwords, API keys, TLS certificates. You do not want those sitting in a plain text config map. For that, we need a different tool.
And that tool is the Kubernetes secret. Now, on the surface, a secret looks and feels just like a config map. It's still a key value store. But the intent is what matters. Kubernetes is designed to treat secrets with special care, providing more security controls around them precisely because they're meant to hold confidential data.
Injecting a secret is also very similar. Here, instead of injecting everything, we're creating just one environment variable called API key. But look closely. Instead of a hard-coded value, we use value from. This tells Kubernetes to go fetch the value from somewhere else. In this case, we point it to a secret key ref, give the name of the secret, and then the specific key we want to pull out. This is a great pattern because it means you only expose the exact secret your app needs, nothing more.
Okay, I need everyone to listen to this one very carefully because it trips up so many people. The data inside a secret is base 64 encoded. Base 64 is not encryption. I'll say it again, it is not encryption. Anyone can decode it in about 2 seconds. It's just an encoding format. For real security, your cluster administrator must enable encryption at rest. That's the feature that actually encrypts the secret data before it's saved to disk inside etcd. Without it, your secrets are just hiding in plain sight.
All right, it's time for the main event. We've got config maps and we've got secrets. Let's put them side by side to make it absolutely clear when you should use which one.
You know, this table really says it all. The decision-making process is dead simple. You just have to ask one question. Is this data sensitive? Is it a password, a token, something you wouldn't want to check in to Git? If the answer is yes, you use a secret. If the answer is no, you use a config map. That's it. The purpose dictates the tool.
So let's wrap this up with some best practices you can take back to your team. First, obviously, use secrets for sensitive data. Second, use role-based access control, or RBAC, to lock down who can actually read those secrets. Third, make sure your cluster has encryption at rest enabled. And here's a pro tip. Consider using immutable config maps and secrets. This prevents accidental changes in a live environment, which can be a real lifesaver. And I'll just leave you with this final thought. Take a minute to think about the Go project you're working on right now. How are you managing configuration? Are there database passwords just sitting in a config file somewhere, or feature flags hard-coded in the source? Think about what you could move into a proper config map or secret. Taking that step is one of the biggest things you can do to build more professional, cloud-native applications. Thanks for joining me.